Okay, welcome back to this section 1.1 video. And we left off last video with you trying out graphing this function here from this table. Gave you a little hint by trying to figure out what your point is at zero, x equals zero, and you should get some type of graph like that. Okay, so let's keep moving forward on the topic of functions. So there is a test called the vertical line test of determining whether a graph is a function or not. Okay, so if a vertical line crosses the graph at more than one place, meaning like if it's a vertical line and crosses a graph vertically twice, like it touches a graph twice, the relation cannot be a function. Okay. If no vertical line can be found that crosses a graph in more than one place, then the graph represents a function. Okay, so sort of a visual representation of this might help. So say I have, something like this, say I have some type of graph that looks, or, let me give you Y, here's your X, so on and so forth. Say I had something that looked like, something like this, just your regular parabola. So if I try and draw a vertical line through this, oops, you know, I'm not intersecting it more than once, right? So if I draw a line, something like that, I'm not intersecting it more than once. So this would be a function by the vertical line test. Okay. And likewise, say I had some type of, function like this, right? And say I wanted to see if this was a function or not. And if I draw it through the graph like such, well, look, I'm touching the graph more than once. So by the vertical line test, this would not be a function, right? And this goes along with inputs and outputs because this means that this specific X value, you're getting more than one output. Okay. So that defies the meaning of a function. But this is just a graphical way to interpret it. Okay, so let's go ahead and get into more graphing stuff. Okay, so here's an example. We want to graph each function. We want to indicate whether it is a function, meaning does it pass the vertical line test. We want to state the domain and range using interval notation. We touched on that in the last video. And list any restrictions, meaning is there anything we can't do? Is there anything wrong with this? So just a little bit of reminder about interval notation, right, for domain and range. Domain and range, interval notation. Okay, so if this doesn't help at all, there's some YouTube videos that might help as well, where you can just look something up. But really, interval notation, you could either have something like this. Say we're on some type of interval from 1 to 4. So your interval could look something like this, 1 to 4, or it could look something like this, 1 to 4 with parentheses instead of brackets, or it could be mix and match. It could be parentheses 1, hard bracket 4, or hard bracket 1 and parentheses 4. Okay, so it could either be these or it could be something called a union. If you remember that from your algebra, it could be something like, 1 to 3, union 3 to 4. That just means we have to stop at like, there's something going on at 3 that we're sort of breaking off and then coming back to it. So just a couple reminders that the bracket means included and a parentheses means not included. Okay, so just some brief review of domain and range, interval notation, things like that, okay? Uh, some review from algebra, right? But definitely try to remember this. And if you are having trouble still, definitely Google some or look up some YouTube videos as well. So, okay. Now, just a little bit of review about that. So what's the question asking us? It wants us to graph this. So here's where it's really beneficial to be familiar with technology because I don't want this is a applied calculus. I don't want to spend too much time like hand graphing these when we have technology that will help us, right? So, if you have a graphing calculator, try it out. But as well, you can use something called Desmos, which is just a free online graphing tool. It's also an app. So I'm going to go ahead and graph 8/3 x minus 2. So let's go to Desmos. I have a Desmos app right here. You can get it as well on your phone. So let me clear this out. And what we'll have here is y equals 8, oops, equals 8 divided by 3 minus 2. Oops, I forgot an x, sorry. 8x minus 2. And there you go. There's the graph. Okay, so that's what it looks like. So instead of us handwriting everything out, which if this was a algebra type of class, sure, we could do that. But, we're going to apply calculus, so we don't need to spend too much time graphing everything. Okay, so here's a graph. And what we're going to do is just copy and paste that onto our notes. So I'm going to do that right now. So I'm going to go back to the notes and let me copy and paste this thing. So image, and here it is right here. There we go. Okay, here we go. So here is our graph on this page right here. This is from part A. And what is the question asking us? It's asking, does the graph indicate the relation is a function? So that means vertical line test. So what we do here is just see if it passes a vertical line test. So I'm gonna draw a line straight through it. It's not touching the graph more than once if I draw a straight line. So yes, it is a function, or relation is a function. So I'll say, you know, I'll say one, yes, a function, and two, what is the domain and range of it using interval notation? So remember, domain is x values. So it doesn't look like it from this graph, right? But this graph is going on forever this way and forever that way. So what does forever mean in mathematics? Well, forever means infinity. So our domain for this would be going from negative infinity to infinity. Okay. And likewise for our range, we're going off forever this way and that way. So what does forever mean? Infinity. So our range is just from negative infinity to infinity. We're not stopping anywhere. And infinities are never included, so that's why it's always a parentheses and not a hard bracket. Okay, so I look at this graph, it's just a regular linear graph, and so I would say no restrictions on this thing. So no restrictions. Okay, cool. So that's number one, right? A lot easier using technology. So if you want to get some practice graphing, feel free to. But other than that, just use technology whenever you can, okay? So second one, we want to graph this guy right here. So same thing, I want to go to Desmos and graph that. So it was y equals 2 divided by x And this is what it would look like. Okay. So let's go ahead and put that in our notes. So image, oops, 1 second. Okay, here we go. So here is the image uploaded. And so we have y equals 2 over x. So once again, let's go through the checklist. Is this a function, right? Let's try the vertical line test. Passes a vertical line test. It's not intersecting more than one. So yes, a function. And now 2, what is the domain and range? So this is a situation where we sort of have this weird situation going on here along the y-axis or at x equals 0. So this really changes our domain and range a bit. So we would have something along this situation where we got to stop at 0 um, and sort of work our way around it. So since we're coming from, for domain, since we're coming from negative infinity and we're kind of stopping at 0, and then we're starting at 0 again and then going on to infinity, our domain here would be negative infinity to 0, right? We're going to union that with 0 to infinity. Okay. Come here, got to stop here, and then keep going forward to infinity. So that's why we're stopping at 0, unioning it, and keep going to infinity. And then likewise, our range would be the same thing. So range would be negative infinity to 0, union 0 to infinity. We're coming from negative infinity. We got to stop at 0 because there's this weird little break right here, but then we can keep going forward to infinity. So you just got to union that. Okay, so if it's been a while since you've seen something like that, that's okay. Just try to refresh yourself a bit or try to understand what's going on here, but that would be the domain and range for that. And lastly, is there any restrictions? Well, yeah, well, since there's just a bunch of stoppage here at 0, our restriction would be at x, oops, our x would be such that x can equal 0 and y can equal 0. Right? So see how that affects the domain can equal 0 and the range, right? We got to stop at 0. Okay, so that's how we would do that problem. All right, so let's move on to part C. Part C, now we don't have to jump back and forth, but part C is x equals y squared minus 4. And so we could just go to Desmos and graph that. So I already have the image right here. So here's what it would look like if we graph that on Desmos. Okay, so that's the graph. And let's see if this passes the vertical line test. So right away, I'm intersecting it at 2 points. If I draw a straight line, this would happen everywhere. Okay, so this means it's not a function. So this won't be not a function. And since it's not a function, we don't have to worry about domain and range and restrictions, okay? So not a function, and we're pretty much done. Okay, so I take care of that one. And lastly, let's look at this absolute sort of value function here. So once again, you can try and enter this in on Desmos, and what you should get something like this. Okay, so you should get something like that. And we'll go through the checklist again. So one, is it a function? I'll draw a straight line, not intersecting it more than once. So this is yes, a function. Two, what is a domain? Remember, domain is x value. So domain, I know it doesn't look like it since we're stopping here, but we're really going off from negative infinity to infinity. No stoppage. No, we're stopping. So it will just be negative infinity to infinity. And here's where our range gets a little different, right? Because yeah, we are going to infinity, right? Because this guy's going up that way, that's going up that way. So there's no stopping going to infinity. But what's the lowest this graph goes? Well, the lowest this graph goes is actually at 4, 3, 2, 1. The lowest it stops is right here at 3. That's as low as this graph goes. So really, the smallest it is 3, and then it just goes off to infinity. So that's why our range will be from 3 to infinity, because the smallest value, y value it is 3, but then it just goes on to infinity. And then any restrictions, you know, no restrictions. Okay, so that's how you would do these problems. Okay, so I know domain and range is a little tough, so just try to try your best. Okay. Okay, so that's it for graphing for this section. And now let's move on to sort of this last part where we are applying some things to functions. So example here, state the quantity that is represented by both the input of the function and the output of the function in part A. So part A says the height in feet of a ball that is dropped from an 80-foot building is given by the function h of t equals negative 16t squared plus 80, where t is time after the ball was dropped. Okay, so what this is saying is that t is time in seconds after the ball is dropped. And this is the input. Okay. And this means that h of t, or h, is height in feet. Let me rewrite that. In feet of the ball dropped from 80-foot building. Okay, so that's what this, our inputs and outputs are. So let me say output. Okay, so now that we have that, let's keep moving forward. So part B says using the function in part A, when we can find that h of 1 equals 64, interpret the meaning of this. So this means that our time t equals 1 seconds and our height h of t equals 64 feet. So this is what that's telling us. So let's kind of write that in a sentence. So after 1 second, the height of the ball is 64 feet. Okay, so that's just interpreting a certain situation using inputs and outputs of a function. Okay, so let's look at another example. So a medication has a half-life of 5 days. If the concentration of the medication in the patient's system is 80 ng per milliliters, and the patient stops taking it, then T days later, the concentration will be given by this function here. And so once it's defined C5 and explain what it means. So what that means is T equals 5. So once it's to plug in 5 and see what that value is and then interpret it. So C5 is just plugging 5 in wherever there's a T. So 1/2, 5 divided by 5. So this becomes 80 times 1/2 to the 1. And anything raised to 1 is just the same exact thing. So it'll be 80 times 1/2, and that's 40. So C of 5 equals 40. Okay, so what does this mean in terms of the question? So we're going to be doing a lot of this, like a lot of explaining what these values mean, since this is a applied calculus class. So what this means is 5 days after the patient stops taking the medication, the concentration of the medication in a patient system will be 40 ng per milliliter. Okay, so we, that's the value that we just found, interpreted in the context of this problem. Okay, so last example here is talking about circumference and area. So the following functions give the circumference and area of a circle with a radius of r. Use a formula to find the circumference and area of a circular plate if the radius is 5 inches. So radius is 5 inches, and this is our input. Okay, so you see how both of these are just functions of r. That just means r is our input. So we're going to plug in 5 and see what our circumference or area is. So C of 5 equals 2 pi times 5, and that's really just 10 pi. Okay, and likewise, we have A of 5, so pi times 5 squared, and that's just 25 pi. Okay, so what this means is that the circumference of a circular plate is 10 pi inches if the radius is 5 inches. Okay, and likewise, the area of a circular plate is 25 pi inches if the radius is 5 inches. Oh, I'm sorry, I forgot the squared. So we're talking about area, so it should be units squared. But yeah, so that's how you would interpret that. But okay, so that's it for section 1.1. I'll see you in the next video. Thank you. Bye.